Hello, hello everyone, and welcome to this midday stream, at least here in Finland. Hey Blue Boy! Sorry I can't watch your stream, I'm here to motivate you as a fellow dev. Well, thank you. Thank you. I will definitely play once released. Thank you very much for at least stepping in for a bit, and you know, all of my streams are available as VODs, so you can definitely check them out later if you are, you know, happen to be at work or whatever. Let's get the starting soon visual out of the way, and we can get started here. As always, do let me know if my audio levels are messed up, or if you can hear me all right. If the music is loud enough or too loud, or if I'm loud enough or too loud, all of that jazz. Let's check the volume levels here. They kind of seem to be roughly what I want and what I expect. So let's see if we can build the game here. Okay, actually the Zig code was already built, it would seem. C++ code is not. So I'm gonna make sure that it actually builds. As I wrote there in the chat, if you are interested in playing the pre-alpha versions of Traction Point, do check out the Discord server, where you can download both pre-alpha 1 and 2. You should definitely play number 2. It's better in every single way. Let's see if we can run the game. Number 3 is coming out kind of soon. I'm hoping to actually release that on Steam, but or at least sort of like deliver it on Steam, right? Remains to be seen if I still want you guys to actually come over to the Discord to get a key for the early versions or not. There's gonna be a proper demo and all of that on Steam sooner or later, but I think for some time still I might want you to come over there to get a key for the playtest. But we'll see when it comes to that. For the time being, you can just download it through a link from Discord. And so if this looks cool, by all means, do check it out. Rightio, so what are we gonna do today? It is Friday afternoon here in Finland. I've been, you know, doing a long week of work. Both on this set piece here, you can see this little derailment thing going on here. Let's actually get rid of that mother vehicle over there. Bye bye. We see that this derailment here is looking a lot fancier than it did previously. I spent quite a long time actually, beginning of the week and last week, or shall we say last weekend is what I'm trying to say here, modeling this thing, trying to figure out how to model broken concrete. I'm kind of pleased with the result, I would say. Audio is fine, sir. Well, thank you. Thank you. You are, of course, free to just, you know, listen to me yap if you want. I know quite a few people, you know, developers, either game developers or just like software developers in general, that just have me on in the background. Not sure how enjoyable that is. But absolutely. If you can't watch, maybe you can listen and then watch later or something. Regardless, so yes, the derailment set piece thing has taken up a lot of my time, and after that I started actually working on some new VFX. Some VFX that you can't actually currently see here in the game right now, because just this morning I removed a bunch of testing code that just like spawned these kinds of effects in this very level at set places, so that you know, I can actually see them without having to actually like play the game, because I'm developing those effects specifically. And what I'm talking about is, let me show you here on a video that I recorded. This kind of thing, right? This is a pretty low resolution video, but let's play it here full screen anyway. So this sort of like distortion effects, displacement, I guess is the technical sort of mathematical term for this effect here. This is supposed to be a sort of a force field thing, which kind of pulls physics objects into it. And what we're looking at here in this very video is like a very early version of this. It's not going to look exactly like this, but it's more like a rendering test, if you will. And what I'm trying out here in this video is like making sure it actually, you know, respects the depth and everything. So it's sitting there on the left side of the vehicle, and now that we actually go behind the vehicle, you should see that the vehicle actually kind of blocks the effect, right? Let's see. Are you streaming on Twitch? I'm not streaming on Twitch, no. I only stream on YouTube. So far, at least. And Anthony says, I'm one of these joined from the Zig Gamedev Discord server. But welcome. Yeah, I just created today a showcase. What would you call it? Blog post there over on the Zig Gamedev Discord server. Figured there might be some interest there in this, even though this is not, you know, 100% Zig. It's going to be quite a lot of Zig. And we're going to do Zig in just a bit here as well. What is the concept? I'm not exactly sure what you mean here. If you mean the concept of the game is sort of like a puzzle exploration, sort of physics-based game thing. A lot of the sort of narrative is centered around this huge vehicle called the Mother, which is this yellow thing here, right? You can switch between vehicles, and at least you can switch between them if they stay, you know, reasonably still. So, come on, Mother. Why don't you stay still? And then you solve a bunch of sort of puzzles and things like that. At least in the single-player campaign. And you can, for example, you can just lift this other vehicle and other smaller vehicles like this. If I can remember my keys, I usually play this with a gamepad, so let's do that. Let's do that as well. Now we can lift this guy, and we can put this guy into, you know, some place where you normally can't reach. This sort of thing. So it's very much like a physics-based thing, and kind of like because of this, I also plan to have a sandbox mode where you can just like mess around. You can place objects in the scene. You can like essentially build things out of the assets that I provide, or you can make your own. Because I'm building all the tech myself, I'm free to release all the level editors and everything if I want. That's kind of the concept of this. The sort of main draw for the like game as a product, if you will, is still the single player campaign. And this mission here, or this level here that we are in, is actually the first single player level. So that is the concept. Anyway, if we shut this down for just a sec more, let's see. We have the VLC player here. Recent media is the gravity distortion field. This thing here. So these are essentially, they haven't really been able to be placed in the level so far, but I just actually exposed today API for this. So I was thinking we would create some sort of small like debug tool in the game, which would allow us to create these kinds of effects and like place them in the level and see if the system that actually like renders and plays back these things work correctly, right? Because I don't know if they will. We might have to bug fix some of them and see how that works. But that would be today's stream's sort of main thing. Alright, sorry about that. I had to reorganize some things here in my room. Alright, so what I was thinking we would do is we would hook this new debug tool thing, which we're gonna create today, into I have this debug menu thing here. If you hold down a few keys and you click in the scene somewhere, you can create other vehicles. You can also destroy those vehicles. You can even just go in and destroy parts of the level here if you want. Like I don't like that tree. Let's get rid of that tree. I don't like that rock. Let's get rid of the rock as well. This is obviously not something that's gonna like really be in the actual final game. But as long as you have this debug overlay here, which shows messages and things like that, you can access this. So you can just. I don't like that mountain there. Let's get rid of it. Is it ZGUI? I don't exactly know what you mean, but I can tell you that I'm not using ZGUI. So this is ImGUI, just standard IMGUI. Dear IMGUI, I guess is the whole name of it, right? Like I have my own sort of UI library, which allows me to create menus like this. This is all self-made, but then in addition to that I use IMGUI for things like this. Oh, the GPU profiler currently doesn't work. Oh yeah, this sort of stuff. That's just IMGUI, and I think we're actually gonna be probably creating like creating an IMGUI thing. Oh yeah, look at this. This is a bug. The what do you call them? The tire tracks. Jesus, I'm having a blackout here. The tire tracks from the previous session are still here. If we now start moving, we can see that it gets refreshed. Like those new tire tracks are getting rendered to the buffer. Yeah, it's just the buffer that doesn't get refreshed. I should fix that at some point. ZGUI is a binding for ImGUI in Zig. Okay, yeah. All right. Okay. No, I'm not using ZGUI. No, I'm doing a whole bunch of binding myself. You might ask, why is that? Well, that is kind of because I need to bind like a whole bunch of stuff. So I just bind everything that I want to bind to Zig from the game engine, which is in C++. I bind everything the same way, so I just bind ImGUI as well. And that allows me to, like, for example, I can switch to not using IM vectors or IM colors, to just using my engine's own vectors and color classes and all of that. So I do a little bit of like quality of life tweaking as part of those bindings as well. If that makes sense. Anyway, let's get rid of these guys. So right, we're gonna have to create something that allows us to place these new force field and shockwave effects in the scene. So shockwave is something that kind of starts small and expands. you know, consider it almost like an explosion or something. And so it plays once, and then it goes away. The force field is essentially like this thing here, right? It starts small, like this is actually like 4 different effects that are running on top of each other. That's why you see like four rings, even though it can be kind of difficult to count them here. But I can tell you that there are 4 of them. They start big and then they shrink, and this thing just keeps running until you actually stop it. While the shockwave is like a one-off effect. You start it and then it ends at some point. I have here this effect count output thing here, which you might be wondering, what is this? Well, that's the runtime actually currently reporting how many of these displacement effects we have running. So if we go to here, you can see here, displacement effect renderer. This is C++. This is on the engine side. Just have an effect count output here, and then if we are actually rendering any of them, we also print how many we rendered, because you might have 2 effects, but you might be, you know, looking at one and the other one might be behind your back. So then the effect count would be 2, but rendered effects would be 1, right? Zigui is not mature enough, so I would have been impressed if this was Zigui. Okay. Yeah, I expose things to Zig as I need them, so I'm sort of tempted to believe that my ImGUI bindings are probably, you know, even less mature, right? Is this your first game using a self-made engine? No, it is not. No, it is not. If you go have a look at my YouTube channel, there is a video called 15 years with a self-made game engine. That should give you an idea of all of the stuff that I've made. It doesn't cover everything, but it covers like 7 or 8 different games or game prototypes, some of which you can actually play, download and play. So that's the spirit of Zig, though, implementing on the run. Yeah, yeah, it is. Absolutely, I agree. And, you know, with the recent changes, breaking changes to Zig, you once again get reminded that, oh yeah, they can just change anything they want. Really. You have the whole rider gate thing, then they removed bounded array from the standard library, and they made some changes to how you're sort of like preferably supposed to use the array list, things like that. The nice thing with Zig is that, like, if you don't like something that they do, you know, like they remove bounded array, you can just yank it out of the standard library and sort of vendor it yourself. Things are typically kind of small and easy to work with in that sense. So that's something I like a whole lot about the way Zig standard library is set up. Rightio. So how would we now then go in and start working on this thing? That's a risk of using pre-version 1 Zig. Absolutely. Absolutely. Yeah. Yeah, there's no way around that. You have to kind of know that you are an early adopter. So what I was thinking here we would do, because if we, let's see if we can actually run it from here as well. Does it load the same level if I run it from here? Yeah, it does. So, you know, if we click here and we spawn a vehicle, what is actually happening is that we're firing a ray from the camera position to here. So it's kind of difficult to show here in this 2D setting. But I'm like, you know, pointing at my screen here like a stupid person, because you guys can't see it. But if you're considering from the eyes of the camera towards a point, you can see this green sphere appearing here where I actually clicked. And so there's a ray going from the camera to that point, and then you can spawn, you know, like a power cell over there, blunk, like that. And we probably want to do something kind of similar here with our new effect debugger, right? So, let's see, I shall be going now. Thank you for your time. Thank you for your time. Absolutely, absolutely. Maybe check out the VOD later on if you feel like it. Anthony also needs to put me in the background. That's absolutely fine. It's absolutely fine. Hopefully I can provide some like light entertainment at least in the background. Anyway, yeah, scene picking. We need to kind of figure out where in the scene we want to place, you know, like a shockwave or a force field. So we need to do some sort of picking. And I was thinking, okay, we're using the left mouse button for a debug action, which is currently only just spawning an object, not necessarily a vehicle. And then the right click is like actually picking the object, so we can pick that tree, which is spruce 4, red 7, and then we can remove it if we want to. Or certain objects have other debug features, like we can set this as the avatar, and then now we are actually that object, right? But still, we need to pick. We need to fire like a picking ray into the scene and figure out where do we land. And so we are actually kind of already doing it here. So this is client in-game state. So this engine uses a client-server model for potentially doing multiplayer and things like that. And so we have a message here which is fired, raw input, mouse pressed. So we get a message when we click with the mouse into the window. We get the button with the mouse X with the mouse Y, and we can get a pick ray from that, and we store that into ray origin and ray direction. This is not how I do things anymore, by the way. Let's do a little bit of cleanup here while we're at it. Why not? Why not do that? Seems like a good idea. So some of this is really early code. Some of this is stuff that, like, you know, may have been kind of like the way you've done things when Zig wasn't quite as advanced as it is currently. This is not one of them though. But some of these things are just like, oh, really gnarly, and the reason might be that they are just, you know, they've been written using an older Zig version. This is not one of them though. This is just how I currently tend to do this stuff. What about this guy? Init 0 as well. Yeah, so we can do raycast result. We can just shorten this guy a whole lot to just raycast result, and then we can do raycast result init 0, something like that. So we get a result, we get a ray origin and a ray direction. The raycast result we only need actually later on. But from the camera, we get a pick ray in world space, the origin and the direction stored here. So that's the ray we can use. We can use that even if we are actually, we can use the same exact code here for doing this new thing, because we have button left, which was the essentially like the spawning. We have one right, which is like the, you know, context menu for the object that we hit. So things like this, we can delete our own vehicle if we want to here. Now doesn't matter how much I click the buttons, we're not going to move anywhere. I need to switch to something else. So we have a middle button. What if we use that? You can see I actually just added this today. So if we click the middle button, might be a little difficult to see here, but it should actually print middle button here in the output, and it is. We just need to kind of stop this. We get this middle button outputs. So let's use that maybe for the new debugger. How about that? And I think we could just very easily add, let's say, a shockwave here if we wanted to. by quite simply spawning one at the hit position. So let's see, what do we want to ray cast against? We have the ray. Then we need to do a ray cast using this render scene. That's absolutely fine. So we do from ray origin to in the ray direction using the hit group mask. So it's like, okay, what do we want to actually hit? And this is a bit mask. So here we're just using mesh. So we can do mesh, editor icon, terrain, decal, light probe. Essentially, it's just maybe the terrain as well. Yeah. So with the bottom right, we're just hitting meshes, right? But with the bottom left, we're hitting the mesh or the terrain, and then we're casting a ray against that. And then we get the result in here in this ray cast result object. So let's do this. Let's do this exact the same thing here, but then we don't do that. So what we can do here perhaps instead is do something like this. I'm gonna shut down the game here because we're gonna have to. I don't have like hot reloading or anything like that working yet. Might have to do that at some point. So if we do effect, or let's do VFX hit position, and we can make that like an optional vector 3. So it's null by default. And here, if we hit something, we store that, right? So we do array cast result dot hit point. And here in update, we can then do, if self VFX hit pos. And we can do basis debug draw. Let's do a sphere. Center is at P, radius is at, I don't know, let's make it 1. And color can be, I don't know, yellow maybe. So yellow like that. We need to get rid of that thing, right? Oh, there are no F's in Zig. So now if we middle click somewhere in the scene, we should get a yellow sphere there. Look at that. Very handy. So maybe we'll want to do like a shockwave, and let's put the shockwave above this position, this point. Or maybe we use actually the normal from it. So if we right or middle click here, because the normal is now sort of slanted, it would appear sort of outside of that. Well, I'm thinking that would be probably a pretty good thing to do. So let's do that right here. And for that to be possible, we need to get this new API, which has never been used, I should add. So it might not actually even compile. Like, you may be aware that Zig is a sort of lazily compiled language. So if you're not using a function, you can have a fair bit of like compiler errors inside that function. And only when you actually use it does it get fully, parsed and compiled. So there might be some funkiness going on here. Let's see. So basically, we want the displacement effect renderer. Let's call this just like the displacement effect renderer, DER. And we can get that from renderer.get displacement effect renderer. Because I just happened to see that we actually got the renderer up here. So that's neat, because with the DER we can now do create shockwave effect. Let's create it at the position that I'm going to calculate here. Let's do const pos is raycast result dot hit point, and then we add raycast result dot hit point normal multiply float how many world units away from the, let's do like 3. That should be a pretty good position to actually use for this stuff. Right, so position is pos. Radius is, I don't know, something. Let's make it 5. Again, no F's or G's there. And then the duration is what should we do? What should we do for duration? So this is in seconds. Let's do like 3 seconds. My strategy is to do a test using testing ref all deculus recursive. Doing this will reference all functions while compiling the test, so you're sure you don't have any dead references. Yes, I do that as well. If we go to basis.zig, you can see here at the bottom, whoa, I have something called a force analysis function, and I do exactly that. So std ref all deculus recursive. I have to be a little careful with what I do that with, though, because the aforementioned bounded array actually doesn't compile if the, let's see if I remember this correctly. It's a bit silly that bounded arrays give compiler errors when fully analyzed unless the type is U8. Right, so only U8 bounded arrays actually work. If you have a bounded array, like a std bounded array, or it used to be called std, so it used to be std bounded array of, you know, thing, where thing was your that would be, that should be a period, obviously, right? This is no longer a thing, actually. But you used to be able to do this. Oh, maybe I'm actually, yeah, okay, I'm still I'm still actually targeting an old enough version of Zig on this machine that this is here, but this was removed in later versions of Zig. Anyway, this has a compile error right here. So in, yeah, I think this is just the bounded array struct. There's a pub writer, which is like if t is not U8, you actually get a compiler error. And I use bounded arrays just like all over the place in the code base, which meant that if I just, you know, referenced everything, I got this compiler error like 200 times or something like that, which is a kind of stupid. So all that to say, I have to kind of list the modules here specifically that I want to test for. But yeah, it's a pretty good way to find dead code. I think we can actually run that by doing build debug tests. And if we're lucky, yeah, we're actually gonna fail something here. Let's look at that. Look at this. Look at this. I'm actually failing things. Here should be a source location. Yeah, evidently I haven't run this in a while. Same thing here. Ah. All right. So now we're getting actually errors. I have something similar. Looks like a bug to me. Well, I reported it, and they told me, yeah, that gives you a compiler error, and then blank stare. So I was like, okay then, never mind then. Right, so we get actually compiler errors in the displacement effect. Let's see. No field of member named toInterop. Okay. What? I think there's supposed to be a toInterop. Yes, there's a toInterop right there. Oh. Yeah, that's supposed to be a vec3. and that's also supposed to be a vec3. So look at that. We already found some funkiness here. Here's the same thing again. Yeah, I switched my asserts sometime back to actually use this sort of source location as the first parameter. Evidently I haven't really gone through it properly. Right, so value of U32 is ignored. Okay, so we get an ID. Let's make sure we can build this in the testing mode first. Yeah, I don't do like a whole lot of just raw C interrupt with Zig. I do a little bit of it. I think there's the most important one is just a single header that I import from my C++ side. Actually, it's this thing that we looked at previously, this message underscore raw underscore input. I'll press this business here. This is not really how I name constants in Zig, right? This looks kind of C++-ish, and that's because it is. It is actually C++. It just brought in through a C import thing. Where is the engine messages? Yeah, it jumps there annoyingly. But here we go. This is like the C import stuff that the core engine requires. I think I have some optional ones in some other libraries, but this one is important because it just uses the engine messages directly here from the C++ side. So this is just like a header with some enums, right? But other than that, I don't really interrupt with C directly, other than through like function pointers and things like that. So I haven't really run into any of like the issues that people have had with like things like translate C and all of that. Right, so now this builds. Excellent. So we're not going to leave it like this, but now if we actually middle click in the scene, if we are lucky, we should see a shockwave, and it's going to be pretty faint if I remember correctly. No, it's not super faint actually. It's kind of large and pretty visible. And you can see that we support several of them. I think we support eight of those guys simultaneously. So we just spam this. You can see that like we have over 8 effects, but we actually only have 8 rendered. Yeah, so you can make some mighty. You can make some mighty sort of heavy displacement here by just putting this. This is just gonna probably completely wank out. Just completely like breaks the renderer if you stack these guys on top of each other. Well, it kind of works, and it even distorts the debug rendering there, which we can see. That's cool. Yeah, it's pretty slow though, I feel. Let's just put that down to 1. Yeah, that's nicer. And I think we should probably do some sort of easing for the shockwave, right? Maybe we can put in an easing there in the shader to make it. I think it should probably like. Now the animation, as you can see here, is kind of like linear. Maybe we can do so that it kind of begins very rapidly, and then it sort of fades out. Air is ionized by the antenna, yeah. Yeah, I don't actually have an immediate use for this shockwave. I mean, I bet I will eventually, but I don't actually have a use case for it yet. Let's stop this now. We can see the shockwave there ever so faintly. How well does it handle? Yeah, it actually handles the depth quite nicely. This has been like the most tricky part of this whole thing, because this is sort of like essentially a screen space effect, and you wanna sort of mask out the effect based on depth, which is obviously not screen space properly, and it's quite tricky actually to do that. If we stack a few of those on top of each other and then pause the game. I'm not fast enough to do that. We have a couple there. Yeah, I think the depth masking works pretty all right for this. Yeah, I do, however, have a use for the force field. So if we change this to a force field effect, and here this last parameter is not actually duration, it's animation speed. So this thing actually never ends. We have to end it, and that's why we get like an ID out of the system that ends the effect. Or you can use to do all kinds of. You can actually also move it around. So now if we create one here, it's fun to see that debug thing there being sort of distorted by that as well. So now we have 3 of these guys kind of overlapping, and the thing just gets horribly distorted. Hey, Personal Heidi, welcome back. Welcome back for some more. Alright, so these things now never end. We should make sure that we can actually end them, and we should probably also make sure that we can move them around. It's kind of difficult to see like where they are in relation to each other. We had another one there. It doesn't seem to work though. And we have 4 effects, 4 rendered. So if we move the camera to about here, we should see them. Yeah, now it goes down. Now we have only one rendered effect. We have 4 of them, and if we turn the camera, we get all of them. So that all works. Nice. Nice. Yeah, this effect just becomes absolutely crazy. It looks like some sort of broken CRT monitor or something. If we go too close. Yup. Wonk Town. Yeah, you can sort of see like the effect kind of like eating into this cliff a little bit here. That happens even though the effect is actually pretty far away from this cliff, distance-wise. But of course in screen space it's right next to it. That's not really an issue though, I think that's kind of just like par for the course. Oh yeah, and they have a cutoff distance that you can also set on these guys. I think it's set to 200 by default, so if you fly away too far, you'll see that we render 0 effects. That also seems to work nicely. Okay, so that's kind of limited though. We should ideally have some sort of debugging window, which we could use to actually specify, you know, what kind of event we want or effect we want to have, and all of that. So maybe we should do that as well. How would I go about doing that though? So we could use IMGUI for that. So if we go to basis.imgui, we have some of the stuff exposed. You can see that not a whole lot, but as I said previously, I just expose stuff as I need it. And so I think we should probably be able to do everything we want with these things. I'm just figuring, I'm thinking here, where would the actual code go and how would it be called? Right, so we have something called register IMGUI callback, which can be used if we want to render IMGUI stuff. But I think we can also just do it from the update if we wanted to do that. But then there's something else, something kind of interesting here, which is the register menu bar callback. Menu bar callback is kind of more useful in the sense that we can use this to create a menu item in the top menu of the game. And so maybe we'll do that. Maybe we'll add a displacement effect debugger or something like that, right? And you can sort of enable that from the top menu. That sounds kind of interesting. Let's do that. So, debug menu items. Let's add this to the in-game state. So I'm gonna see how that actually is called. It's kind of annoyingly wide. I'm just gonna move this off to the second monitor here for a bit. You guys aren't really missing anything. So client in-game state. Basically, we can... Yes, let's do it like this. I'm gonna add something called a... What is it called? It's called a debug overlay imgui callback ID. So displacement effect debugger callback ID. It's a mouthful, I know. Can't be helped. Debug overlay IMGUI callback ID, which is just an int32, I think. Oh, that's a colon, of course. Yeah, it's just an int32. but it's maybe a bit more descriptive this way, what it actually is, right? And in on enter, so when we enter this state, what we can do is we can assign to that thing. This is debug overlay, register, I'm GUI menu bar callback, like so. And then we need to actually have a function here. I'm just gonna write it here. Draw debug menu items. Right. Something like that. That's not Zig. Let's see. All of a sudden. Yeah, I've been writing too much C++ and Zig sort of. First one and then the other, so my brain kind of messes up what the syntax is. So this would be debug overlay, ImGUI callback, init method, the receiver is self, and the type is self, and then debug menu items. But we want that with a small d, of course. Like so. Yeah, that's how you do it. That's how you write Zig. Okay, and so this means that when we enter this thing, we're gonna start firing this function, this debug menu items, and in here we can just write ImGUI menu items essentially, and they will appear there in the top menu. It's also important to remember to unregister that, so we do it here in on exit, self displacement, blah blah, and then we can set this to back to -1. Right. So in here I'm just gonna copy some other code that I had here in another state. So right, menu debuggers or whatever. Let's call this in-game debuggers, because we are now in the in-game state. Right, so if this is now just essentially standard ImGUI stuff. So this would be displacement effect debugger, right? Selected false, enable true. And if we click this, and let's just print something. Debugger. Go, go, go. It expects an argument, does it? Yeah, it does. Of course it does, because it's a member function. That should be better. And what is this? Oh, it actually, okay. Yeah, that should be unregistered, right? Unregistered takes the ID. Yeah. Yeah, that should be better. So my thinking here is that if you want to debug spawn these effects, you come up here to the menu, and we can see in-game debuggers, and we click this displacement effect debugger. That now shows us debugger here in the output, so that's great. That works. And this would show us a window, and if the window is active, is open, if you do this middle click, you actually spawn these effects, right? How about that? I think that'll be kind of handy. because then we have the sort of the logic for spawning these VFX things. They sit behind a window like that, so you don't accidentally spawn those effects into the level. If you don't mean to do that, you need to open the window and have it open for that to happen. And you can also change, what kind of effect you want to spawn. Again, I'm not sure we're actually gonna keep this code around, but at least for a little bit. So let me see if I can find some more ImGUI window code in this file. No, nothing there. But I think we actually already have some windowing code. If not here, then at least where is it? Probably here. That's a pop-up, okay. Pop-ups and some menus. Just called like imgui.begin, isn't it? I think that starts a window. Yep. Yeah, here we go. The fence maker. Yeah, that's good. I'll bring this guy over to the side so I can look at it. I'm not actually very experienced using imgui, so I have to kind of remind myself how to do these things every now and then. Alright, so let's create a new struct for this thing. So let's do const displacement effect debugger. And that's a struct, right? And with the self is this. That's what I usually do. And in here we have some data. So we have two types. We have a shockwave and we have a force field. We can quite simply have it as a bool for now. But I wonder if we have actually basis renderer displacement. Yeah, we don't have a type enum for that yet, so I'm just gonna keep it as a bool. So spawn shockwave. That's boolean. Let's set it to true. Radius is a float. Set it to 5. Duration, also a float. Set that to 2 maybe. Alternatively, we have animation speed, and that can be equal to 1. So that's some data that we're gonna want to actually feed into this thing, the create force field effect thing here, right? Or create shockwave effect. Then we need whether or not this is actually active, right? So is active bool equals false. Separate that. That's sort of like a separate thing from the rest of these guys. And we can create one of these dudes here. What? That's not how we do it. We do it like that. There we go. And we can also store this hit position in the debugger, so we have everything kind of neatly. Let's jump there. So hit position. And let's just keep that as a non-optional. Vec3 0. Right, and then it can have a pub fn draw window. And this would be probably self, and then a writable pointer like that. And then here in update we can do if self displacement effect debugger is active, then we do self displacement effect debugger draw window, and that is where we can then write our IMGUI code. How about that? And then in this callback that we added previously, where did I put it now? Alright, it's right here. Here we quite simply do self dot displacement effect debugger is active true. And then I'm gonna copy some code here from the fence maker tool that I created previously. Oh, vec2. We need vec2 as well. Vec2, basis, math, vec2. It's right there. Right? Title. This is displacement effect debugger. Take out some of that. There's a button. Yeah, I'm not sure we need any of that. So what this guy will have is, well, first of all, you should probably hook this up into the is active, right? So if we do self is active there as the boolean, and then IMGUI, basis IMGUI. It's like radio button. Do we have radio buttons? We don't have radio buttons. Maybe we should expose some radio buttons for ourselves. Alright, let's go have a little bit of a look at the IMGUI demo. The IMGUI demo can be enabled here on the C++ side by clicking Show Demo Window, or defining Show Demo Window here. So this is just probably like IMGUI 101 for many of you people who are like really used to working a lot with IMGUI. But you get this window which is sort of built into IMGUI, right? And here if we go to basic, so we have radio A, radio B. So what I'm thinking here is that you know, if we click this guy, we don't get the window yet, apparently. For some reason, why don't we get the window? Well, I don't know. We'll figure that out. But if we had a radio button like this, which was like spawn shockwave, and then the second one which would be spawn force field, right? And that would be kind of handy. So radio A, radio B. Let's search for that here in the radio A. And we can find it here. So it's just radio button. And what are the parameters? IMGUI. V button, shortcut to handle the above pattern when value is an integer. Right, okay. Okay. Yeah, I think I've actually used that that shortcut thing. Right. It's right here. So that would be like an integer, and this is the integer value that we actually want to set. That's very handy. So let's use that. Let's expose this guy. That should be pretty easy actually to do. Before we do that though, let's make sure we can actually see that window there. So what do we have? Begin, end. Let's add some text here. Hello. Whoa. Hello. Oh, cannot assign to constant. Yeah, okay. So we need that to be a non-const one. And now we don't have that, but we do have, let's see, if, you know, maybe that should still be an optional. That's actually kind of handy. That should still be an optional one, right? And then we can set that hit position to that. So hit position, then we go here, and then we do hit position, like so. So now, hopefully, if we click here and we click here, yay, we get our displacement effect debugger window. And we can shut it down. We can open it back again. Excellent. Excellent. Okay. And we probably don't need the demo window there anymore, so we can probably shut that down as well. But yes, we should expose this radio button function now. And that is done using my own custom binding tool called Bind-A-Lot. Let's see here if we find IMGUI. IMGUI is right here. Yeah, we don't have any radio buttons. So this is a little bit of a strange way maybe to do bindings. This Bind-A-Lot file, which kind of looks a little bit like a mix between C++ and C. This is not like any programming language actually. This is sort of like an interface definition language. But the idea here is that you have these things called classes. A class can be like an actual class in C++, or it can just be a group that you want to sort of well, group together a bunch of functions that you want to bind. And here you can see that I've exposed all of these functions. They are, however, essentially C function prototypes. So this is what the function that you will want to be called on the C++ side looks like when we call begin list box in Zig. And it takes doesn't take like strings and vectors, it takes interrupt strings and interrupt vectors. And these are well, they are structs here in C++, but they are extern structs in Zig. So if we go to imgui.zig, and we find one which has a vector of some sort, like this one here, button. So imgui button takes an interrupt vec. These are extern structs, which of course means that they map to the same memory sort of layout as a struct with two floats would in C, which means that we can then just treat one as the other when we do the actual call. So that's neat. Okay, so the thing we need to do here to actually map that radio button function is to copy it from here and add it as a new one. I don't know why these things are, the scroll ones here are kept separate. Maybe we'll keep them separate. Add the thing right here. So it looks like this. It looks like bool radio button. Then it takes a string, which is the label. It takes an integer pointer and an integer. And rather than returning bool, at some point there was a bug in Zig, which meant that, like, I think on Mac OS systems, I got some crap in my booleans if I returned a boolean by value, which meant that I had to wrap them in integers. I think that bug has probably been fixed, you know, a long time ago already, but I'm still wrapping them in something I call int bool, which is essentially just a type def for an integer. So let's do that still, and then at some point I'll probably have to go in and you know, actually replace those with proper booleans. Right, so that is essentially what we want. Oh, but now I'm a little confused again because this is not Zig. It is supposed to be C at this point. So radio button, we take a label, and as an interrupt string we take a pointer to something we want to actually modify, an integer, and then we take the actual integer value. That makes sense. And the way this generation now works is that we actually run a small tool on this file, class bindings.bindaLot, which is this thing that we just added to. You can see that it didn't find any errors or warnings, and it has actually added a few new things for us here in the generated code. So let's go and have a look. First of all, it created a type def for the function pointer that we're going to want to be calling on the C++ side. And it added that function pointer to a list of parameters for another function pointer, which is the, you know, binding the whole IMGUI API to Zig. And then it does like a essentially gives a function pointer. So this is a function pointer in Zig. Star const fn is a function pointer in Zig, and so it created the function pointer sort of prototype here and gave it a name, basic Zig IMGUI radio button CB. CB stands for callback. And then it created an instance of that and set its value to undefined because we don't know it yet. And then it added that to this bind IMGUI function here on the Zig side as well. So this export fn bind IMGUI thing will get called by the game engine when it starts up, and it passes all these function pointers to it. And then this thing goes in and stores them somewhere so that we can actually call them. So we get all of that for free. The thing we need to add on the C++ side is the actual function that will get called when we, you know, call IM radio button or IMGUI radio button. And so I will need to actually find that, and I don't remember where it is. So let's see, end list box. Something like that is supposed to be found somewhere. Basic Zig interrupt. That looks good. So here is where we actually want to have this function will get called. And you can see here we actually get some compile errors here. It complains about things, and that is because we changed the prototype for it, and it went below end list box, so we need to insert our new function there, and the errors go away. So that means that now when we call IMGUI radio button from Zig, we actually end up in this guy here, right? And here is where we can make the actual call. So let's see. Radio button, That's supposed to be that one. Then we have v, and we have v button. And since we return as an int boolean, we will do something like this, right? So if that returns true, because that returns an actual boolean, then we return a 1. I think we can actually technically just cast it to an int boolean, but whatever. And yep, that should be everything we need to do on the C++ side. Now we just need to wrap this up nicely on the Zig side so that we can actually, you know, we don't have to construct an interrupt string in the Zig code to be able to call this. We should just be able to pass an idiomatic string in an idiomatic Zig string is what we want to be able to pass there on the Zig side. And it should just work. Alrighty, so that succeeded. Good, good, good. So the way this works is that we need to add this to essentially 2 places. This first one is one that I haven't actually had for very long, but I do these days. End list box, let's search for that. End list box. So this is called api.zig, and this thing exists because technically I support WebAssembly modules these days. So the idea is that you can, for example, create a mod for the game and package it not as a DLL but as a WebAssembly module. And the reason why we allow that is that WebAssembly modules are, at least in theory, a lot safer than a DLL, right? Because it's sandboxed. But the WebAssembly sort of communication between the game and the game engine, or the mod and the game engine, whatever you whatever scenario you want to think about here. That is different if you're writing a WASM module instead of a DLL, and that's why we have this API thing here, which actually splits it up into 2. As we can see here, that this is a compile time check. So we either leave out this part or we leave out that part, and almost everything here it just gives a compile error because I just haven't exposed IMGUI to WebAssembly yet. But like, ideally I would implement all of these things. A lot of stuff has been exposed to it, and so you can already play actually an example mod that I made for the game, which adds like a flying scout vehicle to the game, which is running as a WASM module. So a lot of stuff already works, but not everything. And as you can see here, evidently IMGUI is not one of the things that currently are supported in WASM. So we fall down to this thing, and this is the code that we looked at previously, the thing that actually got generated for us by the binding tool. So now the last thing we need to do is we need to go to IMGUI and add like a nice function for us to call here, like the actual like Zig idiomatic type using function. So that would be radio button, and label is then a const u8 slice, which is the idiomatic Zig string, right? What were the names of those? Was it V and V button? Yeah. So V is a pointer to an I32, and V button is just an I32. And then this returns bool, right? So we have to convert the label to an interrupt string, so interrupt label. Then we can just copy this line here. We can do radio button instead. And we pass it V and V button. Like so. Alright, so a lot of explanation, not a whole lot of code, but a lot of explanation here for your benefit. Feel free to ask me if I just didn't explain things properly. Anyway, with a bit of luck, we can now call radio button, and that is one more IMGUI function bound to Zig. So let's go to, what was it, in-game state. It's right here. Draw a window, and here is where we can now then do this thing. Let's have a look. Yeah, that should be fine. So I do realize now, however, that we want an integer here, not a boolean for this. So let's just, instead of having spawn shockwave, let's have effect type as an I32, and we set it to 0. So with that, we should be able to do basis.imgui.radio button. Seems like we have to restart ZLS here to be our body. There we go. So shockwave is 1, and that would be address of self dot effect type, and we set it to 0. And then we have probably basis same line. Don't I have same line here? Oh, come on. Basis IMGUI. Yeah, same line. Okay, I just somehow failed. Radio button, and this would be force field, and same thing. So address of self.effect type and 1. All right. I wonder if we actually have to expose some like float fields and things like that as well. Well, let's see. Int ignored. Ah, yeah. There's a return that's missing from there, and I think we probably need to, ignore the return value here as well. Let's try this out. Alright, so now the radio button works. It of course still only spawns those force fields. Doesn't matter if we set it to spawn shockwaves. So let's fix that up. So if you see here, actually not even there. We have them here instead. If self displacement effect debugger effect type is 0, then we spawn a shockwave. Else we spawn a force field. Like so. Get rid of that. Alright. And here we can do self. That would be radius. And then this is duration. And that would be animation time, or animation speed. Right, so now then. Let's see. Shockwave, shockwave, shockwave. Force field, force field, force field. Excellent. Yeah, driving through those effects is kind of wonky. Can't be helped. Might have to sort of fade them away by distance or something like that. But yeah. Shockwaves. Shockwaves. Yeah, you can see a little bit of sort of like weird sort of jumping here, and that is just because we are actually hitting that limit of 8 rendered effects if I do that. So that weird sort of jumping has to do with like effects that suddenly become visible because the other ones have died. That sort of thing. Yeah, we should really tweak that shockwave effect and give it some sort of nice sort of quick start, I think, and then slow down towards the end. This looks like some sort of wave and some pretty thick fluid rather than like a shockwave from an explosion or something. Okay. So, what about these other ones then? We have the effect type cover, we need the radius, duration, and then animation speed. So what kind of basis? I'm GUI. What do we have here? Do we have any handy widgets for that? Probably not. Maybe we'll need to expose some more. And if I do that, I will just kind of do it and not explain the whole thing, and it will be a lot faster this time around. Let's show the window, the demo window again. So what kind of thing should we have here? Input float. Maybe some sort of slider, right? Slider float from 0 to 1. Ah, yeah, it's logarithmic, so you can get very fancy with like small values and then still reach the larger ones. Okay. Hello Marcus, welcome back. It's been a while, hasn't it? It's also a drag int, drag float. Would that be nicer? Yeah, you can double click it and then you can input the value 4.12. Drag float, would that be nice to expose? I want something like ideally with just a very simple. Yeah, this is perhaps kind of tricky, or is it? Drag scaler, label, data type, IMGUI data type. Okay, that's an what is it? Is it an enum? It is an enum, okay. Yeah. Okay. Yeah, we can work with that. The data is a void pointer, float, speed, right. Yeah, okay. might be nicer to have some sort of... Yeah, here we have a drag float. MGUI slider flags. I have some iMGUI enums exposed here, but apparently not that one. We can do that as well. Expose that as well. It's fine. MGUI slider flags. It's kind of annoying to actually find these guys, right? Here we go. There they are. Yeah, maybe we'll expose like the float slider, maybe the int slider, stuff like that, and then we'll have, I'm sure we'll have some use for that. So drag float, drag sliders. Okay. What's the name of these others? So we have, that's drags and that's sliders. Right, they're essentially like the same thing, but with a slightly different kind of, slightly different sort of visual feel. Like you can drag this outside of the window, but this one kind of stops. Yeah. Yeah, that makes sense. Let's expose at least like drag float, slider float, and probably the same with the integers. I think that makes sense to at least expose. I'm gonna expose the vector ones and things like that later, but we don't need like all of those. But to be able to do that, we're gonna have to expose this guy first. So let's do that as well. I'm going to copy these prototypes though. I'm gonna copy them into the bind.lot file, into the IDL, which we can find here, just as commented out. These kinds of, what do you call them? Prototypes, function prototypes, so that I can then easily toggle them or translate them essentially into the format that I need them to be in, like that. And then we'll turn our attention to this enum here, which we can find here. So we'll get this guy, and we need to go into, not that, but let's close all the other ones, and then we go to imgui.zig or imgui, whatever, and yeah, we'll essentially plonk this in here and turn it into a Zig enum instead. So enum, and I'll wrap these as I32, like so. And then we'll take away that part. And I think the invalid mask I think I'll leave that out probably. And then there was some issue here with the fact that like you have these things that are ORed together like this, you know, always clamp. Would be clamp on input and then clamp on zero range. There was some problem here with me actually doing that previously. You can see that you have allow when overlapped is an OR of 1 shift 8 and 1 shift 9. And then I have commented out the original one here. And so the idea is that I'd basically just like take these two and copy their values directly into this. Because there was some issue which I don't remember exactly now what the problem was. we can see that this is 1 shift 9. And then we OR it together with clamp 0 range, that guy, which is 1 shift 10. Like so. And that is sort of like how I've gotten around to doing all of this. I'll leave the invalid mask there. And then I have this handy little helper function called asInt, which just make it so that you don't have to type @int from enum. We just type .asInt instead, like so. So that would be the slider flags exposed. That's essentially all we need to do. We treat it as an integer in the binding, so we don't really need to, you know, bind it specifically. We just keep it here as it is. That's nice. And now, maybe I'll do it the other way around this time around. So I will go to the bind-a-lot file and find these things that we want to bind. I'm gonna copy these guys, and I'm gonna start by actually doing the sort of user-facing stuff. Let's just put them at the end, actually. Let's put them at the end here. Over there. And so here we would have pub fn drag drag float, and this would be a label, which is a string. We have v, which is a pointer to an f32. We have v speed, which is an f32 v min, which is an f32, and a v max, which is the same. Then we have format, which is a string. And then we have these flags that are IM GUI slider flags. Like so. And this returns a boolean. And that would be 1, right? How's the drag int? It's probably just the exact same thing, except these things are integers, right? Yeah. And Zig doesn't unfortunately support default values like this. So you can actually set it to like 1, 0, 0, and blah, blah, blah. So if we want more versions of this, it also doesn't support function overloading, by the way. So one more versions of this that have, you know, less parameters to set, we're gonna have to create some sort of simple version of this, you know, drag float simple or whatever. Drag float basic. But enough about that. Let's create drag int, and we set that to an i32. Speed is still a float. That's an i32 and that's an i32. You could use a struct as a parameter input if you want defaults. Yeah, I could. That's true. So then the calling would be something like drag float, and then you would, you know, set this to like dot v equals 1, dot v min equals 2, and so on. Yeah, that could be a way. I'm not a huge fan of that API style. But that could be a way to do it. And then the struct would have the default. Yeah. We'll see. I'll have a think about that if I want to actually do it that way. That was a good suggestion. Thanks. Let's see. How do the slider ones differ from the drag ones here? If we put the parameters next to each other, so we don't have a speed one here. Is it the same otherwise? These guys also don't have. Some of them don't have like default values. Other than that, it looks like they are basically the same, right? Yeah, essentially basically the same. So let's just copy these guys and we'll call them slider, and we take speed away, get rid of the speed, and slider int, and get rid of the speed again. Something like that. Alright, that looks good. So let's do the ideal part then. Again, I'm gonna use the int booleans, even though I'm not sure if that's actually really needed anymore. But I think I'll do like a mass replacement of that at some point if needed. When I have verified that it actually works. So float, that would be a F32 pointer. The speed. That's I'm doing it again. Yeah, that's not what I want to do. I want to basically copy this thing. Float v speed. We want to get rid of the default values here. Can't have default values. This guy needs to be an interrupt string. And this guy probably needs to be an integer. So flags. There's a C missing from that one. Something like that. Because we mark that as being an I32. So we'll treat it as an integer. That's good. And then we have drag int. And it has that as an integer. Speed is still a float, but then it has those as integers. So that was that. And then we have the other ones, which were the sliders. Slider. And they don't have the speed. Right. I think that's it. I think that's what we want to have here. So again, we run this through a batch file. Batch file gives us no warnings, no errors. Excellent. Yeah, I'm sorry, we'll get back to the shockwaves and force fields in a little bit. This got almost turned into like an IM exposing stream all of a sudden. But this should be everything we need now, I think, for the VFX debugger that we're working on here. Shouldn't be a whole lot more IM stuff this time around. Right, so here we need to do drag float, drag int, and then slider float and slider int, like that. And as you can see, we can compile the whole thing without IMGUI support, so we just need to wrap everything inside of this check here. Maybe we'll call that like F. And so IMGUI button up, IMGUI drag float. That's V. That's V speed, V min, V max. That's F. And then that would probably be IMGUI slider flags. Flags. Like that, right? Isn't that how I have done it before? Yeah. Just cast it to the thing. Okay. That's excellent. And then we do the same thing here, except this is drag int. And then we have slider float. And we have slider int. Let's see if that builds. I think it should. Yep. So that's the C++ side. And then we just need to do the Zig side. And we already have the functions here in IMGUI, these guys, but we don't have anything to call yet. So we need to add to that API thing that we looked at previously. So let's go here to the end of the IMGUI stuff. Set scroll from position Y. Yep, that's that function. Okay. So I'm gonna copy these guys. And it should look almost the same, but not quite. So we need to prefix them with, well, we don't need to, but that's my standard. Prefix them with the bind-a-lot class. And then these guys should be I32s. And then the strings should be interrupt strings. Or interrupt string const pointers to be specific. To be even more specific, they should be C const pointers to interrupt strings. So replace all of those with those. And here we can quite simply do the same we did previously. Let's not worry about the WASM stuff yet. That should be a C int, technically, like so. Yeah, let's not worry about the WASM stuff yet. Instead, we're just gonna pass everything through as is, basically. So label v speed, v min, v max, format, and flags. That should be everything we need. And then we do the same thing here. So drag int and drag int. And then we have slider and slider, and we don't have the speed. Like so. That should be it. And then the last thing we need to do is actually call this. So essentially the only thing might be a little bit of work here is to actually convert the format. Interrupt format. So we need that for all of these guys. Just plonk them in here on every single one. and then we can do, let's see, we can return if basis bindings API IM-GUI drag. Yeah, again we need to restart the ZLS. I don't know why ZLS doesn't pick up on these things specifically. So now we have drag float and drag int there. So that would be address of interop label. We have v speed, v min, v max, address of interop format, and flags as int. Something like that. I think there is a what is it called? Bool from int from bool. There's no bool from int. Huh. Okay. Why is there no bool from int? Well, I'll do it with the return if then. Whatever. Whatever, Zig. And this would be a drag int. This is a slider float, speed away, and then we have slider int. Oh, slider. There we go, slider. There we go. How about that? We're done maybe exposing IM-GUI for this stream. So, the first thing we would probably want to have then is the radius, right? So, basis IM-GUI. Let's make it like a slider float, I think. Let's put the radius. And that would be the address of radius, self.radius. Minimum would be, I don't know, 0.5. Maximum 20, something like that. Format, what was it? The format is a little, yeah. The format one is tricky because because it uses the C formatter for that, right? So what I'm thinking actually here, if we go to IM-GUI demo, you can see that it actually we can go to imgui.h and look at slider float. Slider float. So it's %.3f. Now that is obviously not a Zig formatter, so I don't really necessarily want to even expose that to Zig. Or do I? I don't know, maybe I do. Maybe it's just something that you have to know that, okay, that's supposed to be like a C formatter, formatting string. I don't know. Let's get rid of that. What do we have? Expected type bool found int. Oh, right. That should be better. Yep, that works. Yeah, you can double click that and input things there, but I bet we can probably enable that with the flag, right? Always clamp. No? No input. Or control click, huh? Is that how you're supposed to do it? Control click or enter key. It was actually like a double click thing here. I don't know. Let's see. It doesn't work for some reason. It might, maybe some other stuff that I have to do. Well, anyway, can we actually, like, if we make a very small force field over there, and then we make a large force field over there. Yeah, that works. That works. That's cool. Let's make some changes. First of all, I'm gonna disable the demo window. We don't want that. Like so. And then, you know, if self.effect_type equals 0, this is a shockwave. Else this is a force field. So here we want to have duration. Rodation. What? Duration. Like so. Yeah, those values are probably fine. And animation speed, if we have the shockwave or the force field, animation speed should probably be smaller to, like, I don't know, 5 maybe. Like that. And maybe we should have a button to kill all the effects, right? If basis I am GUI button kill all effects. I think we can make that be like -1, -1. Isn't that how ImGUI wants to, like, determine the size itself, if I remember correctly. Let's make this active by default, so we don't have to go through that menu every time to open it up now that we are working with it. Basically every time we run the game. Alright. Ooh, kill all effects is a big one. It's a big one, isn't it? Yeah, of course this doesn't do anything yet, but we'll make it do something. Yeah, the height is a bit much. Let's make it 20. Something like that. So basically what we need to do is we need to pass in draw window. We need to pass in the renderer, right? Let's see here. There we have the renderer. And we can pass it there. And then this guy would take renderer, basis, renderer pointer is what it wants, and this guy then needs to get the displacement effect renderer. Let's call it again DER, like so, and here we can do DER kill all effects. we play a bunch of things, we can shut them down, and perhaps more importantly, if we add a bunch of these force fields, we can kill them from there. Make it a really, really fast one. The animation speed doesn't seem to work yet. Maybe I just didn't plug it in. Did I? Animation speed. It's right there. Oh, I'm adjusting the wrong value here. Duration. So that's what we want. So now we can make force field, and we can make a really, really fast force field. Ooh! It almost makes the screen sort of shake. Jesus. Oh, please. Hey Tutu. Welcome, welcome. Yeah, I think that the duration for one of these guys should probably be shorter, and we should plug in some sort of easing into the thing, so it looks more like an explosion shockwave rather than, you know, like a, I don't know what kind of slowly flowing fluid this thing is. Also, I'm gonna just delete that output from there. It's kind of annoying. I think we've established that thing actually works now. So let's go into here and find the displacement effect renderer, and then do, yep, those can go away. Well, water drop ripple thing, yeah, it's something like that. Like I mentioned previously that I have, or I will have, use for this force field thing pretty soon. It needs to look different than this though. Since I designed this thing, I kind of got some second thoughts on how I actually want it to look. But it will basically be this sort of like a continuous inwards pulling thing. Actually have use for that. I don't really have use for this shockwave, at least yet. However, I think it might be kind of neat to have this sort of shockwave, because it's essentially like the same effect. It just goes the other way. And there's only one wave instead of 4 currently for the force field, and it just plays essentially once. So I kind of figured that, yeah, maybe we'll just add a shockwave as well, and then, you know, if we have some explosions at some point, we can play one of those guys, and it should look nice. But yeah, I think I'm gonna want to plug in some neater easing into this guy. Let's add one more field here, which would be distance from surface. Float 32. And currently it's set to 3, so we can keep it at that for as a default value. And then we'll just plug it in here. So distance, distance. Yeah, that's probably fine. Distance from surface, and then we quite simply use it here. I'm gonna want to have some extra size, extra width to this guy. Like 600, why not? Oh, I need to build this. It's the thing when I'm working with, like, you know, half of the time I'm working in VS Code, and the other half I'm working in Visual Studio, the proper one. And the proper one, by default, kind of builds your code if you just launch it. VS Code doesn't. VS Code just runs whatever you have currently. Right, so now if we can sort of run it on the exact surface itself, that should probably be possible to have it at 0, I think. Maybe even negative. Let's make it like -2 is the minimum. Perhaps you have different kinds of energy containers in the future, which contain different matter, some antimatter, and some otherwise unstable thing which could distort its surrounding space. Something like that, yeah. Yeah. I mean, we already have the power cell, right? So if we make an experiment here, let's put a power cell there. Oh, it fell over. Stupid power cell. Let's see if we can have it stand up. There we go. Would the real power cell please stand up? And then there was a distance to surface, distance from surface. Look at this. Now immediately we can have a use for this negative one. Radius. Set the radius to quite small. We want the force field version, by the way. And now we can, actually we don't want that, we want this. Yeah, I don't know if that looks very good, but you have to kind of use your imagination a little bit. Oh. Yeah, would you want to approach that thing? The yellow debug sphere is sort of maybe a little annoying there. Oh, we can easily remove it by clicking somewhere else. Yeah, I think that looks kind of dangerous. Yeah, I can spoil as much. I think I've actually said this before, that the mother vehicle is supposed to get a sort of an antimatter crane for picking up large amounts of small objects, and so the force field effect is something that I've sort of thought for a while that, okay, how should I actually like you know, signal to the player that the force field is active. And this is kind of what I came up with. Not sure how well it will actually, you know, read currently, so that's something we're gonna have to figure out. And I'm thinking that the actual final effect will have to be sort of like almost like a ring, where there's like distortion along the sides, but perhaps not so much in the middle, so you can actually see what you picked up without it just being super annoying. So that's kind of like the reason I have this effect going now. I'm kind of happy with it actually, considering that I can like mask it out based on the depth now. It's actually not super easy to do. I think it works reasonably well. And I think it's safe to say that the chromatic aberration is a bit maybe a bit too crazy in its current form. And we can tweak that. So here we have the actual displacement effect. It's just something that I've messed with. It's based on some Shockwave YouTube video tutorial that I found at some point. So we can probably just like make that much smaller. Oh, that's the shockwave displacement. I want the force field displacement. There we go. Yeah, so now you can see that the chromatic aberration is a bit nicer, maybe. I think we might want to actually like, okay, you can go super crazy with it. I think we might want to actually scale it with the radius. Yeah. Anyway, we'll see. I'm gonna start building that other crane very soon, because I need it for this mission. I'm not necessarily gonna be spoiling things the way I do currently for you guys when it comes to the single player campaign. You know, a whole lot in the future. But at least if the plan kind of holds, then this will be the very first thing you do in the whole game, and that is actually like helping clear out this derailment of the monorail thing here. And so I think it's not really a spoiler if you hear that on stream, that the very first thing you do in the game is help clear out this thing. And so the mother vehicle will get like a gravity distortion field crane as a second crane. That's why we have these kind of fixture points already here. I'm not sure yet if it's going to go there on the side or if it's going to go on the back. But there's going to be another one which helps you lift things. Significantly smaller things, but you can lift like a whole bunch of them. So that is something that's gonna happen, and for that I want that effect. I want that effect to look nice. We're spoiled enough with you doing. Yeah, I know. I'm gonna have to stop doing that so that you guys have some reason to actually play the single player campaign. Like the campaign is already sort of like specced out almost from beginning to end, like narrative-wise. Of course, it remains to be seen if I actually have the chops to build the whole thing as I want, but yeah, it's supposed to be the first mission, so I don't really have a problem with showing off some stuff here. Rightio, should we maybe look at that easing for the shockwave? Let's get rid of that guy. So let's make the radius significantly larger. Do I want to actually like I want to make this. I don't want to take away that yellow sphere there. Might want to do that. Let's comment that stuff out. Right. And then let's go to easings. So what kind of easing do we want to try here for the explosion shockwave? We can do some really kind of crazy easings by using like an elastic one, of course. Let's see, actually, do I have some easing stuff here? I'm gonna open my shader folder. Open folder. Like so. Yeah, apparently not. I might want to like create a header for that, I think. Let's create a new header here. Call this easings H. So, let's try something that's maybe more what I had in mind. That function is here, is out quart. I was thinking it would be maybe something like this, right? Let's call that float. Float number, what? X. Like so. There's a power though, so it's not super performant necessarily. Power XY. So we just take that away. Is that it? I think that's it. And then we can do we go to full screen effects and we go to the displacement. We include that thing here. So include HLS will include easings H. And then here in the force field displacement, shockwave displacement here, just run this T through that thing which we called, what was it? Is out quart. Right? Let's see if this works. Did I shut down the game actually? Apparently I did. So, Shockwave. Bring that down. Alright, looks like that. And what if we build that thing? Look at that. It's already nicer. Let's go to easings again. Get one of these really crazy ones. Ease out elastic. Oh, there's a copy button there. Handy. Right, so float. 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 Method pi. Do I have a pi constant? There's math. There's pi. Okay. Yeah, so we can do. This is reasonable. Include math.h. And then we have pi. And I like to fully qualify these as floats. Alright, so this is, yeah, that obviously won't work in HLSL. Might have to, I don't know, change this a little bit. But let's see what we get by just copying this over as is first of all. Alright. This is an interesting thing. There's like the two ternary operations here. What's the order of this? It's like you know, if x is 0, 0.0, then we give it a 0. Otherwise, if x is 1, we give it a 1. Otherwise, that. So that's like, it's essentially like that. That's the whole second part, I think. Right? It's almost like they had, like they're trying to eliminate branches using this, but I don't think this will eliminate any branches at all. I think it's just gonna be just as many branches as having like if statements there. But whatever, let's try this. Try it out. Oh, that failed. What do we have? Unexpected float constant sim, no matching one parameter. Huh? Wait. What? Let's maybe extract that into like its own thing. Or like D. And then just replace that with D. Like so. Yeah. Let's actually do fleed. What? Float E is basically like this. Wait a minute. Let's do that. E. So now this should be a bit easier to read at least. If x is 0, then we return 0. Otherwise, return that. There's a syntax error here though, which I can't quite seem to find. I wonder if is pi. Yeah, that should be fine. You can just replace it with that if you want to be sure. Unexpected float constant. Okay, we're gonna have to look at this. The annoying thing with my shader compiler is that you have to kind of look at the line numbers here in the generated, the fully expanded one. So 594 is it? Yeah, it's not happy with this. That's an HLSL function, right? Sinus is an HLSL function, which takes a single parameter. Yeah. I don't understand what the problem is with this line. That's a float. That's a float. And that's a float. And oh, that's not a float. What the hell is that? Yeah, that looks like a version number or something. Okay, that explains it. What is that? 10 minus 0.75. Yeah, like that. That should be a float. We can't fix it there though. We need to fix it here. There we go. There we go. Now we have it. So let's see what this looks like. Oh Jesus. Duration. Let's make it larger. Longer. Yeah, you can't quite see it because it's like it's right at the end, if I'm not mistaken. No, it should actually be in the beginning, huh? Ease out elastic should be in the it should be in the beginning. Or well, the small bounce is at the end. Yeah. The small bounce is at the end. So what we can do if we just want to see what it looks like is like one minus that, right? And then now we should see maybe. Yeah, now we can see the small bounce there. Yeah, but it sort of really doesn't work with that at all. Let's look at some other easings, some other sort of sensible easings for this. We had the ease out quart, ease out cubic might also be nice, and it's also a math power there. So I'm not a fan of those powers. Float. This one should though look much better with this. We have an ease out cubic. Yeah, we need the duration to be much smaller. That's kind of nice. I think I like the quart better though. Yeah, this kind of almost looks like it could be some sort of explosion thing happening, right? Or something. Let's just copy this path here to the beginning of this file. Easings is very handy. So is out sign is at least, it should be sort of performance wise it should be better because it doesn't have any powers in it. We can just use pi here, that should be completely fine. Math pi, like that, and then just take that away. But it's not as, you know, it's not as perhaps immediate as those other ones. We can run it through the easing twice though if we want it to be more immediate. We can just do this and that should work. Yeah. Oop. That's the thing, there it is. Just run it run it through it a few times. And now it's just like a bunch of sine waves that's driving it. So, yeah, I don't know. It's okay, I guess. How is that compared to the 1 quart? It's basically the same. Yeah. Yeah. Yeah, well, it's kind of handy, this little debugger that we created. Pretty useful for doing this sort of design work. I think I'm pretty much where I need to be to start working on that crane. Right? Like if we look at this guy, and then we pretend this crane that it has here is this other crane thing that we're gonna create. Then this is sort of like the distance that we're gonna want to see that effect at. So here we can let's see. I can't actually press these buttons now without actually moving that crane. That's a bit stupid. I can at least pause the game, can't I? And then I can probably spawn. Yeah. But then the thing doesn't actually play if the game is paused. That's a bit stupid as well. Okay. Yeah. I'm gonna set that as the avatar, and then I'm gonna move the camera roughly here. Right, so I can actually clear the the dialogue here. Game state. Yeah, I can clear the avatar for myself. Okay, so right. Let's consider we have the crane at. Oh, you know what? I don't need to do any of that. I can just set the avatar roll to something else, and then the crane doesn't move. Stupid me. I'm stupid. Stupid and bad. Okay, so we have the crane like this, and then we have. Let's pretend we have some. We don't need to pretend. We can just put some cargo here on the ground, like this. I want to sort of slurp up with this new thing, which is definitely not a cargo crane as it is here. It is instead this new sort of anti-gravity thing. So if we set the distance from surface to something pretty close to 0, actually, probably. That's fine. And then the radius. Here we can now create one of those guys. And it will look something like that. And we can see that it's a little annoying maybe to have that effect be that strong, but I don't know, maybe it's not that annoying. But it can be a little bit annoying if we're sort of this close with the camera. We're trying to see what we are actually picking up. I think for that effect is probably too strong. So this is what I was thinking, that like, okay, we might want to actually we might have to redesign this effect to be almost sort of like a halo around the thing, with less of the distortion stuff going on there in the middle. So you can actually see what you're doing, but it should be sort of clear all the time that, you know, that is the range of the crane. If you can see sort of like a distorted halo around the tip of the crane, should be kind of evident that, okay, that is the range of the slurping force, the force that slurps all of the small objects into it. Right, that is my reasoning for this. But that's cool. I haven't been able to actually like see this sort of stuff previously when we haven't had that debugger, so this was already a success in that sense. And I can also see that again. This, I'm just so excited about this depth clipping of this effect here because it works so well. I like the effect. It immediately tells me what's up without knowing what it is. Yeah, I'm glad to hear it. I don't really like it yet. I mean, I do like it. I like it quite a lot, but I don't think it's exactly the effect that we need here. But yeah, I get what you're saying. And indeed, that has been my goal with this. That it should sort of signal that, hey, something is pulling stuff here, and I think it will be even cooler when you can see all these things sort of getting pulled toward this centerpiece here, this gravity well. I don't know what to call the thing yet. It's like gravity well crane, or gravity disruption crane, or attractor crane, or whatever. What is it gonna be called? But yeah, I'm glad it sort of telegraphs what is happening. That is the whole idea. You should immediately see, okay, that's what's happening. It also serves the purpose of showing the range of this thing, right? You should be able to navigate this crane around objects and knowing roughly what the range is, so that if you don't want to slurp some objects, you should be able to navigate it around those objects, or perhaps even adjust the range, and the effect should sort of show that, reflect that. Yeah. Yeah, I think this will be good. I think this will be good. Alrighty then, folks. I think I'm gonna go have a glass of water. I've been yapping again for quite long, and then we'll figure out if we actually want to do something more in the stream. So I'll be right back. Alrighty then. Yeah, we also need to make sure that this effect doesn't get super obnoxious when you get too close to it. I mean, I think one way to do that is just to have it so that it's not as intense there in the middle, that the intensity sort of fades away towards the center of it. And then you need to have your camera sort of right at the edge of it like this for it to be sort of become obnoxious. Right. I mean, I think we can hack that quite easily into the shader here. We want to try it out just very quickly. Let's see. So we have the this is the entry point. We have a text pos, which is the position of the current texel or fragment that we are processing. So maybe move this off to the side a little bit. We can see the thing here as we are modifying it. So text pos is the position that we're currently processing, and we go here to displacement, and then we go to force field displacement. We're passing the text pos there. Are we passing the sphere screen position? Yes, we are. That's the second parameter, actually. Right, so influence text pos screens, sphere screens pos, sphere screen pos, and sphere screen radius. I think using those we can modify this influence here. This is not necessarily how I want to do this in the future, but let's see if we can sort of mask it out a little bit. So so let's actually, before we do anything else, let's calculate the distance. So distance to center would be text pos minus sphere screen pos. Right, something like that. And I'm hoping that these are not in the same unit. Don't remember exactly. So distance to center is like, you know, it goes from 0 to sphere screen radius. Right. There was one thing here with this remapping function where, like, I think we're wrapping from an old range to a new range. That's not the one we want. We want this one. Remap float is there. Yeah, old min cannot be larger than old max, so this actually won't work. What we are just doing. No, actually it will. Yes, it is. It's exactly gonna work. Yeah, exactly. Yeah, this will work. This will work. Except I did something stupid. Oh, I don't have an equals sign there. There we go. All right, so now we're doing that a little bit. It's already sort of easier to read here in the middle. I think probably we'll want to just limit that even more. Yeah, that's starting to look like kind of what I was going for, or what I was thinking. 75. Right, like this might be something to kind of consider. I think it gets sort of squished a little bit, and I think that has to do with the aspect ratio, right? It looks like the aspect ratio is squishing it. We're gonna have to probably do this separately for, let's see, that would be X. No, actually. This is either times aspect or divided by aspect. It might be the other way around. Yeah, there we go. Now we have it. Now we have it as a as a round sort of circle again. Right, so now it would be nice to have it a bit more, sort of tighter though. Yeah. I'm just hacking here and seeing what happens if I hack it a little bit without any real plan. Oh, I'm normalizing it right after. Yeah, that would be why. I think we need to actually do this. Yeah, we need to do it here for that to actually have an effect. Yeah, there we go. Okay. Now we're doing some funky stuff. Funky. Yeah, I can see here that the range of that doesn't quite work. Yeah, that also sort of gives it a little bit of a sense of you know, pulling things together towards it, but I don't think that's necessarily enough to tell the player sort of how large the range of that thing is. But something like this could be kind of cool. It's a very sort of faint thing now. You can sort of see that, okay, it is on and it is pulling things towards it. Right? This gives it the sense of doing that. It is of course not doing it yet, but it's sort of giving it the sense of, oh, okay, yeah. This thing is, there's some sort of field. So yeah, something like this, right? That's the original. At least like this one was pretty nice. But yeah, I think it's too heavy. It's too heavy still, and needs to be toned down. But the idea is pretty solid, I feel. There's a pretty big sort of distortion of the space-time continuum there. Might have to make it a bit more sort of gamey and sort of, you know, descriptive rather than being like just purely sort of like a visual thing. And then of course if you're driving into that thing yourself, you're also going to be sort of affected by it, but I think that crane is not going to be powerful enough to actually lift this car. That's why you have the cargo crane for that. Yeah. Yeah, it's starting to look pretty cool. So if this is interesting, stay tuned. I might do a little bit of streaming of the actual like working on that crane. The crane, which should be actually significantly easier to make than compared to the cargo crane, because the cargo crane has probably like 50 joints between physics objects. This crane doesn't have a single one, not a single joint. Oh well, it might have, but like the prototype I made some years ago of this kind of like gravity distortion crane thingy didn't have a single joint. It was just pulling things together, sort of like a radial fashion. So I'm hoping that's something that I can use for this as well. That should be fun and good. So if that sounds interesting, stay tuned. Maybe subscribe. Maybe join the Discord server if you want to play the pre-alphas. Pre-alpha 3 coming out relatively soon. I know I kind of promised or at least aimed to release it within August, and it's no longer August, so I kind of failed with that. But I think the improvements that I made recently, even though they are pretty significant, aren't sort of gameplay-wise significant enough to really make it much more interesting than Pre-Alpha 2. So I'm just gonna postpone it a little bit more to actually make sure we have some proper new stuff to play for you guys. Right? I want it to be sort of a thing when you get to play a new Pre-Alpha. Things like this crane here is part of that hot stuff. So it will be out pretty soon, but it's not quite done yet. Can't be helped. Anyway, folks, I think that's enough for this stream. Thanks very much to everyone who came to hang out. Remember to like and subscribe. It's been pretty slow going on the channel lately, so I would appreciate it very much if you liked, subscribed, showed your friends who might be interested in this stuff, and so on. And we can maybe get a good amount of hype build up in time for the Steam page reveal, which is supposed to happen pretty soon as well. Anyway, like, subscribe, do all the YouTube jazz. See you in the next one. And have a good weekend, everyone.